Yes, dear students, today in this lecture, what we are going to discuss means we are going to discuss about the first stationary waves. What do you mean by stationary wave? We are going to discuss stationary waves. We are going to discuss what is meant by stationary waves, which we are going to discuss. Fine. What is meant by stationary means when two waves traveling in opposite direction they superpose each other. They superpose each other and stationary wave of standing pattern can be observed. Pattern can be observed. So what they're telling, two waves should travel in opposite direction condition. So let me choose. For example, I'm having one rigid boundary here. We're having another rigid boundary here. So this is a string here. So about this, let us assume one wave is traveling in this direction. One wave is traveling like this. This is about which axis? Positive axis. You know that y1, how can you write it? y1 equal to a1 sin omega t. We can write it. Let me write here about one. This is y1. Well, what I'm writing, y1 equal to a sin omega t. I'm going to write here. A sin omega t minus kx. Now, positive axis means it's going about positive axis. Now, let me choose another wave. Another wave is traveling opposite to that. Let me draw first, then I'll change the direction. So second wave is traveling in this direction. We choose. So this type of pattern is observed. So what is the pattern means here? This is a pattern which you can observe. This is nothing but standing pattern which you can call. And wave is called stationary wave, which you can call it as. So if you observe here, no, y2 value, how can you write it? Means y2 equal to, I'm writing like a sine omega t plus kx, I'm writing. Because wave is traveling about which direction? Negative direction. So omega should be positive and this will also positive, or omega should be negative, this will also should be negative. I'm taking like positive here. If you observe here, about the points which I'm indicating here, about this point, about this point, about this point, about this point. What is the particle displacement is minimum. So these are called what means nodes, NODES. If you observe about this point and about this, what you can tell means here, amplitude is maximum. These are called what means antinodes. Antinodes. So first what we can define node. What is meant by node? We need to define. What is meant by node here means we can tell that where the amplitude is minimum. The point where the amplitude is minimum. Is minimum. For in this case, how many nodes is there? For this case, what we choose in this case? 1, 2, 3, 4. So nodes is how many is there? Nodes. Number of nodes equal to 4 is there. Next, we need to define antinode. We need to define. If you want to define antinode now here, where the amplitude is maximum, now if you observe about this point, amplitude is maximum. About this point, amplitude is maximum. About this point, amplitude is maximum. The point where the amplitude is maximum. So how many antinodes is there in this case means antinodes? Observe here 1, 2, 3. So 3 antinodes is there. For example, this case which we took in. Now how to add these two waves we have to learn. How to add SHMs means we already learned in our oscillations chapter. So how to add SHMs? We need to write y equal to what we can write it here, y1 plus y2. So or what we can write it, y can be written as what? Y2 plus y1 also. SHM both are sine functions, we can add like this. So how I'm writing is y equal to y2 value I'm writing like this first one. A sine omega t plus kx we're having, plus another one what we're having, y1 a sine omega t minus kx. A sine omega t minus kx. If you observe in both functions, amplitude we taken same here, both amplitudes. This is also a, this is also a. You can take a common. Y equal to what we can write means a sine omega t plus kx plus sine omega t minus kx, which we know here. So what I'm considering means here, I'm considering this part like C I'm choosing. I'm considering this part like D. Then if you observe these both, sin C plus sin D from it came. So we know that in trigonometry, from trigonometry entities, sin C plus sin D equal to what we can write it here? 2 sin C plus D by 2 into cos C minus D by 2, which we know here. We're going to apply same formula here. See, if you apply the same formula here, what will get it? Y equal to a sine C plus D by 2, Nana. C is this value, this is this value. So sine C plus, C is how much? Omega t plus kx plus D value omega t minus kx. Omega t minus kx minus kx divided by 2. Next, what we're having? Cos C minus D. Cos C value is how much? Omega t plus kx. Omega t plus kx. Observe carefully. Minus D means if I send minus here, no, minus omega t plus kx, it will become directly multiply with minus omega t plus kx divided by 2. If you observe here now, plus kx minus kx got cancelled, plus omega t minus omega t will get cancelled. Then what we got it here? So we'll get like this. So what will get it? Y equal to a sine omega t plus omega t will be what will get it? 2 omega t by 2 and cos kx plus kx can be written as 2kx. 2kx by 2 we can write it here. This fellow will get cancelled. Here what will happen? These two will get cancelled. Therefore y equal to what we can write here? Y equal to, I'm writing this fellow first, I'm writing next this function first. Second. So y equal to be written as a cos kx and sine omega t will get it. So in this case, what we can take means this can be written as amplitude net amplitude. How means y equal to what I'm writing means a net sine omega t. I'm assuming here wave equation. We assume now if I compare this equation, a net value how much will get it? A net can be written as what here? A cos kx, we can write it here. This is nothing but amplitude of the wave, which we can discuss. Amplitude of the wave. Listen, once again I'm going to explain here what happening means. So y1 plus y2 or y2 plus y1 we can do a sin omega t plus kx, y2 value, omega t minus kx, y1 value. So if I take a common, no, it looks like what? C plus d, sin C plus sin D formula we know, 2 sin C plus D by 2 cos C minus D by 2. As usual, we are adding first case and cos function is subtracting. Kx will get cancelled, omega t will get cancelled, omega t plus omega t will be 2 omega t by 2, 2 will get cancelled. Another thing what we are having, omega t minus omega t got cancelled now, kx plus kx will be what we get it? 2kx by 2 we got it here. Therefore, what we get it here? Y equal to a cos kx, this function first, and sin omega t. This equation I'm going to compare with y equal to a sin omega t I'm going to compare. Therefore, a net equal to what we get it here? A cos kx we got it. This a cos kx is nothing but what we are discussing, amplitude of this resultant stationary wave which we discussed here. CDS, listen one note here. So what we are choosing means a note. So generally how to write wave means, if I take any wave like this, no, one thrust plus one trough is called what? No, wavelength, which we can consider wavelength lambda. So in the case of stationary waves, what happening means it's going in opposite direction. So like this we're getting. This is wavelength. For example, we are choosing only this portion. If I'm choosing from here to, I'm choosing here only this portion means how much I can take means total wavelength is how much we chosen? Lambda. Then this can be chosen as what? Lambda by 2. You have to remember this value. For example, this is lambda by 2 means how much this will become? This value also will become how much? Lambda by 2. For example, I'm choosing from here to here only. Observe the point. From here to here. The point A to B. So lambda by 2, half of that is how much? Lambda by 4. This value is you have to remember. Complete wave is nothing but lambda. So only one wave is nothing but what here? Between two nodes, wavelength is how much? Lambda by 2. Between one node and one antinode is the distance is how much? Lambda by 4. These are the values which you have to remember to solve the next questions. See, in this slide, what we're going to discuss is here. Formation of stationary waves in pipes we're going to discuss. Formation of organ waves. Formation of waves in organ pipes we're going to discuss here. Fine. What are you going to discuss? Formation of stationary waves in argon pipes. Very important concept as well as for your boards and as well as your competitive exams. As it is NCERT, we're going to discuss here. So first case, what I'm going to discuss means here, I'm going to discuss about closed pipe. Closed pipe. What is meant by closed pipe means the pipe which is closed at one end. The pipe closed at one end is called closed pipe. For example, let me choose here pipes here like this. Conditions I'm taking. Three modes I'm taking here. Like this, three modes I'm taking here. So what is the first possibility means? First possibility will get like this, So the wave can come like this, can go like this. So this portion wavelength how much means we from one antinode to one node, lambda by 4. Just now we discussed that. I explained it. From here to here, what is the possibility I'm taking means I'm taking like this. One more possibility. That wave going like this, let us also like this. So what will happen? From here to here, wavelength is how much? Lambda by 2 we have discussed. This here to here is nothing but lambda by 4. Next, third possibility, what we are taking here means we are taking third possibility like this. Like this, we are taking like this. This you know that this is lambda by 2, this is lambda by 2, this much how much we can change? Lambda by 4. And each case, what is the pipe length means I'm taking lambda, sorry, L I'm going to take here. Each case, pipe length is how much? L we are going to take here. So what are the possibilities we're checking here? So first, this is called what we can call it means first mode. This is called what we can call it as second mode. This is called what we can call it as third mode, which we can call it as. How many nodes, how many antinodes is there? We have to check. If you check here, no, this is one node, this is one antinode here. So what we can tell? One node and one antinode. Next case, 1, 2. Two nodes, 1, 2. This is maximum amplitude, this is maximum amplitude. Two nodes and two antinodes is there. Next, third case, 1, 2, 3. 1, 2, 3. Maximum amplitude, observe 1, 2, 3. Minimum amplitude, 1, 2, 3. Three nodes and three antinodes, which we know here. And I would like to discuss one formula here, which we already learned in starting of the chapter. We know that what is the frequency formula means frequency velocity relation. Velocity is nothing but what we know. Velocity equal to f lambda we know. F equal to what we created here? V by lambda. Switch this fellow here, it will come to denominator. So this is nothing but frequency formula, which we are going to use in this derivation. Let me discuss each case first. First case we observe this length is balancing with what wavelength? Lambda by 4. Na? So what I can tell means here L equal to lambda by 4 I can tell. Therefore lambda equal to what we can write it? 4L. 4L. So if you want to find frequency, frequency equals to V by lambda 1. So F1 can be written as V by lambda. So lambda value how much we got it? V by 4L, which we got it. I'm keeping that value like that only. V by 4L. Next one, what I'm going to check means here, next case I'm going to check here. Lambda by 2 plus lambda by 4 we're having. We're going to add this thing. So this is balanced with what length? This length L. Therefore, L equal to what we can write it here? L equal to lambda by 2 plus lambda by 4. L equal to 2 lambda plus lambda by 4 we can write it. Therefore, L equal to what we get it here? 3 lambda by 4. Lambda equal to what we get it here? 4L by 3. Frequency formula what we know, F equal to V by lambda. Therefore, F2 equal to V by lambda value, how much we are having? 4L by 3. 3 will come to numerator. Next, third case, if you observe here, no, this is the length, lambda by 2 plus lambda by 2 plus lambda by 4 is getting balanced here. Therefore, L equal to lambda by 2 plus lambda by 2 plus lambda by 4 is there. Therefore, L equal to what we are going to write? If I take LCM, no, 2 lambda plus 2 lambda plus lambda by 4, we can write it. Therefore, L equal to 5 lambda by 4 will get it. Lambda can be written as what? This 4 will come here, 5 will come to denominator. 4L by 5, which you can write it here. So if I substitute F3 value, no, what is frequency? V by lambda. Lambda value I'm going to substitute V by lambda 4L by 5. 5 will go to numerator. These are the values which you wanted. F1 value, F2 value, F3. 3 more we check here. Now we need to check ratios of these frequencies. F1 is to, F2 is to, F3. And if you keep doing on like this, what will get it here? V by 4L is to 3V by 4L is to 5V by 4L. V by 4L, V by 4L, V by 4L will get cancelled. Means 1 is to, 3 is to, 5 is to, and 7 is to, and so on, which we can get it here. This is the frequencies ratio in which case here? When pipe is closed at one end. So, okay, then what all this can be called as means? So first what we can mention means here. This first one is called what means? Fundamental frequency. Fundamental frequency. So what is the fundamental frequency value? F1 equal to V by 4L. In the questions they can ask you directly. Fundamental frequency. And this is called first overtone. First overtone. And this is called second overtone. And this is called third overtone. We can keep telling like this. And these all can be called as basically what means harmonics. This is first harmonic. First harmonic value is how much? V by 4L. This is called second harmonic. Second harmonic value can be called as what here? F2 equal to 3V by 4L. If you observe, 1 is to 3 is to 5 is to 7, these are all nothing but what we can tell harmonics here. And which type of harmonics present here? 1, 3, 5, 7 means only odd harmonics present here. Now what I would like to check means here closed pipe, I would like to check this value. If you observe here now, I'm going to check F1 value, F2 value we're having now. So F1 value, how much we're having? F1 equal to, let me change the pen color. Yes. F1 equal to how much we're having? V by 4L. F2 value, how much we're having? F2 equal to 3 into V by 4L, I'm writing. 3V by 4L. Okay. Now I'm going to check F2 minus F1. F2 minus F1 value, how much will get it here? V by 4L will come common. 3 minus 1 is nothing but 2. Therefore, 2V by 4L will get it here. So 2V by 4L means 2 1 ja, 2 2 ja. V by 12 will get it. That's why we can conclude one thing here. So what I'm going to conclude means Fn minus nth fundamental frequency minus nth harmonic minus Fn minus 1 value should be equal to how much? V by 2L, which we can write it here. So this is the answer for this question. And this formula is very important for solving JEE numericals and CET numericals here. As it is, they will ask you in JEE, CET and NEET numericals, they can ask you here. For CBSE and board exams, this will be very important derivation will come for 3 marks or 5 marks. 5 marks, they will attach one numerical, otherwise the derivation they will ask you for 3 marks, which they can ask you here. See, now we are going to discuss about formation of stationary waves in open pipe. We are going to discuss here. Open pipe. What is meant by open pipe means? The pipe which is open at both ends is called open pipe. A pipe which is opened at both ends is called what we can call as open pipe. See, open pipe case, what we are going to take means this is a case which we are going to take. So first we are going to take pipe here. Second, we're going to take one more mode here. Third, we're going to discuss one more mode here. Same length only, but for diagram comfortability, I'm just increasing length of this pipe here. So this pipe length is how much? L. This pipe length is how much? L only. This pipe length also L. I'm just showing you magnified diagram. It is also. Now, what we are taking means first case. What is possible means. So this is a possible case. First case. This is a possible case. So what will happen here? This is node. This is antinode. This is also antinode. What we can tell here? One node. Two antinodes possible. We can tell here. This wavelength is how much? Lambda by 4. This wavelength is how much? Lambda by 4, which are given in node. Second possibility, what is possible here? Second possibility, this is a possibility. So what we can tell here means, we can get like this. So this wavelength is how much? Lambda by 4. This wavelength also how much? Lambda by 4. This wavelength is how much? Lambda by 2. This is one node. This is one node. Two nodes we'll get it here. How many nodes? Two nodes we got it. How many antinodes we got it? 1, 2, 3. 3 antinodes which we got it. Next, third possibility, what is possible? Let me check. So third possibility is this. Like this. This is the third possibility, can be possible. This wavelength is how much? Lambda by 4. This wavelength is how much? Lambda by 2. This wavelength is how much? Lambda by 2. This wavelength we know that lambda by 4, which we know here. Lambda by 4, lambda by 2, lambda by 2, lambda by 4, which we know here. Nodes, antinodes we discuss now. 1, 2, 3, which we got it. So 1, 2, 3 nodes we got it. 3 nodes means obviously how many antinodes? 1, 2, 3, 4. 4 antinodes, which we get it here. And frequency formula F equal to what we learn? V by lambda, which we learn. So we need to remember this formula to solve the frequencies of these cases. So what we are going to discuss means first case we are going to discuss. First case length, if you observe, this length is balanced by lambda by 4 plus lambda by 4. No? So L equal to what we can write it here? L equal to lambda by 4 plus lambda by 4. Therefore L equal to what we got it? Lambda by 2. We send this 2 here, no? Lambda equal to what we get it here? 2L. So F equal to, you know that, V by lambda. So F equal to V by lambda means in the place of V only is there. In the place of lambda, I'm going to substitute 2L, which we got it. This we can take as F1, and this is called fundamental frequency. Just now we have discussed. Next case, what we are going to discuss is, we are going to discuss F2 value. If you want to discuss F2 value, no, check. Lambda by 4 plus lambda by 2 plus lambda by 2. Therefore, L equal to what we can write it here? Lambda by 4 plus, this one is how much? Lambda by 4, this is lambda by 2. Lambda by 4 plus lambda by 4 plus lambda by 2. Lambda by 4 plus lambda by 4 is nothing but how much? Lambda. Quarter plus quarter is half. Half plus half is full. So lambda by 2 plus lambda by 2 is nothing but lambda, which will get it here. Therefore, what we got it here? Lambda. So therefore, lambda equal to what we can write? L. F equal to V by lambda, no? So F equal to, in the place of lambda, what I can substitute? L. But I'm multiplying numerator and denominator with 2 here. So I'm writing like 2V by 2L I'm writing here. So I'm just multiplying and keeping here. Why? Because while finding the ratios, it will become easy. Next, third case we're going to discuss here. What is the third case means? Third case can be L can be balanced by lambda by 4, lambda by 4, lambda by 2, lambda by 2. Therefore, L equal to, first one is lambda by 4 plus lambda by 4. Then lambda by 2 plus lambda by 2. Plus lambda by 2 plus lambda by 2. Observe here carefully. Lambda by 4 plus lambda by 4. That's nothing but lambda by 2. Lambda by 2, lambda by 2, lambda by 2. So L equal to what we got it here? 3 lambda by 2, which we got it, yes. So for lambda equal to what we can write now? 2L by 3. So what is the frequency formula? F equal to V by lambda. V by lambda. Lambda value how much we are having? 2L by 3. 3 will come to numerator. This is third frequency which you can take here. Now what we need to do is we need to calculate the ratios of this thing. If you observe the ratios, no? V by 2L common, V by 2L common, V by 2L common. If you take the ratios, this V by 2L, this V by 2L, this V by 2L will get cancelled. How much remains here? 1, here 2, here 3 remains. Therefore, if you calculate the ratios, no, what we get it means F1 is to F2 is to F3 equal to 1:2:3 we can get it here, and so on we'll get it here. And this 1 is called what here means fundamental frequency, and this 2 is called what we can call it as first overtone. This 3 is called what? Second overtone, which we can tell here. Now, this is the frequency ratios formula in which case of what? No? In the case of open pipe, a pipe which is open at both ends is called open pipe. Now, if you observe here, no, which type of harmonics present here? 1, 2, 3, everything is possible. Even and odd harmonics are possible. Therefore, we can mention that clearly here. Therefore, all harmonics are present. All harmonics means both even and odd. If you observe here, no, F2 minus F1, if you check here, no, F1 value check V by 2L, F2 value 2V by 2L, F3 value 3V by 3L. Therefore, Fn value, if you want to write here, how can you write here? Fn can be written as 1, 2, 3, we can write, na? Therefore, Fn equal to what we can write? Fn equal to what we can write? NV by 2L, which you can mention here. For second one, you check second frequency, 2 we can substitute. For third frequency, 3 we can substitute. For example, if I want to check here, F2 minus F1, I would like to check. F2 is how much? 2V by 2L minus V by 2L. V by 2L will get common. 2 minus 1 is nothing but 1. So what will get it? V by 2L. So if here also if I check, no, Fn minus 1, sorry, where is this? Fn minus 1, no? Yes, here also if you observe, Fn minus 1 value, if you check, no, how much we got it here? 2L. The difference between two frequencies, consecutive frequencies, how much we got it? V by 2L, we got it as earlier. Fine, dear students, here we are going to discuss about what means formation of stationary waves in a stretched string. We are going to discuss here. Formation of stationary waves in stretched string in a wire. We are going to discuss here. So generally we know that what is the velocity or speed of the transverse wave means, you know that transverse wave speed already, what will need? Transverse wave speed we proved in the last lecture, last lecture, V equal to under root T by mu, which we did out. Just keep this result aside. So, and what are the possibilities we can find? Let me check here. So I'm taking first case like this. These are two rigid ends. In between them, one wire is there here. So what is the possibility if I make oscillate it here? One wave can form like this. What is the wavelength means? Lambda by 2 we know here. Next possibility what we can take means, next possibility, this is can possible. Next, what is the third possibility means? Third possibility we are taking like this. This is how it can form, Nana. This is the third possibility which you can take here. And each case, how much length means? Same length which we are going to use. This is the length of the string L. This is the length of the string L. This is the length of the string L, which we know here. So this can be called as what here? This can be called as first mode. This can be called as what? Second mode. This can be called as third mode. In first mode, wavelength is how much we are going to take means here lambda by 2 from here to here. Here this complete wave now here lambda by 2 plus lambda by 2 lambda by 2 lambda by 2. This value lambda by 2 lambda by 2 lambda by 2 which you know here. How many nodes, how many antinodes we are going to check here? First point if we check 1, 2. So what we can tell here? 2 nodes, 1 antinode. This is the maximum displacement which we are having here, no? 1 antinode. If you observe this case, second case, 1, 2, 3. How many nodes is there? 3 nodes is there. How many antinodes? 1, 2. 2 antinodes is there here. 2 antinodes. Third case, 1, 2, 3, 4. 4 nodes is there here. How many antinodes? 1, 2, 3 is there here. How many antinodes will get it? Means 3 antinodes which we got it. And frequency formula earlier, how we remember means V equal to F lambda, we got it. So F equal to what we got it? V by lambda. Same formula which we are going to use in this case also, which we are going to use here. Now, if you observe here now, first mode, second mode, third mode we are having. Now, let us assume for first mode. Let us discuss about first mode first. First mode length is how much L? This balanced by what is the wavelength? Lambda by 2. Therefore, what we can write it means L equal to lambda by 2. Lambda equal to 2L. Frequency equal to what we know here? V by lambda. V by lambda. Therefore, F1 equal to, if I substitute lambda value, V by 2L, which we got it. This is called as usual first fundamental frequency, which we can call it as. Next, we are going to check about the second mode here. Second mode, if you want to discuss here, no? L equal to, how much is there here means lambda by 2 plus lambda by 2. L equal to lambda by 2 plus lambda by 2. Therefore, L equal to what will get it here? Half plus half will be full, lambda. Therefore, lambda equal to L. F equal to V by lambda, no? Therefore, F2 equal to V by lambda. In the place of lambda, I'm going to substitute L, but I'm going to multiply numerator and denominator with 2L to find the ratios easily. This is first overtone value, which we got it here. Next, second overtone, if you want to check now, we want to discuss about the third mode here. So, third mode. In third mode, if you observe here, length value is balancing over lambda by 2 plus lambda by 2 plus lambda by 2. So, lambda by 2 plus lambda by 2 plus lambda by 2. Lambda by 2 plus lambda by 2, 2 lambda by 2 plus lambda by 2 is 3 lambda by 2. Therefore, L equal to what we got it? 3 lambda by 2. So, lambda equal to what we get? Send these 2 here. These 3 will come to denominator. 2L by 3, which will get it. Therefore, lambda equal to 2L by 3, we got it now. F3 equal to frequency can be as V by lambda. Velocity upon lambda value, how much we are having? 2L by 3. 2L by 3, which we got it. This is second overtone value, which we got it here. As usual, what we are going to check here means we are going to check the ratios. V by 2L, 2V by 2L, 3V by 2L. V by 2L, V by 2L, V by 2L will get cancelled. If you find the ratios now, F1 is to, F2 is to, F3, and so on. If you do know, 1 is to, here how much remains? 2, how much will remain here? 3 is to, and so on, which we can write it here. These are the frequencies ratios in which case? In stretched string case, which we can discuss here. Fine. So this first one is called what we can tell here. This is called, first one is called fundamental frequency. Second one is called what we can tell? First overtone. Third one is called what we can tell it as second overtone. If you observe harmonics, 1, 2, 3, 4, 4, 5, and so on, you'll be getting here. So what we can observe here? Here, both even and odd harmonics are present. Harmonics are present, which we can tell here. See, we know that transverse wave speed, what we know here, V equal to, we learned that V equal to under root T by mu in last lecture we derived, or just now also we written there. We are going to substitute that value here. So if you write now, F1 value, F1 can be written as what we can write 1 by 2L. In the place of V, I'm going to write this value 1 by 2L under root of T by mu, will get it. For example, F2 you write now, F2 value how much will get it? 2 in 2 by 2L under root of T by mu, we can write it. F3 value, if you write here, what will get it? 3 by 2L into V value under root T by mu will get it. F3 can be written as 3 by 2L into under root T by mu. If I want to write nth frequency, Fn can be written as what here? N by 2L into 1 root T by mu, which will get it here. If you want to check the ratios or differences, if you want to check here, no? So if you want to check F2 minus F1, I would like to check F2 minus F1. If I check F2 minus F1 value, how much will get it here? F2 is 2 by 2L, right? So what we can tell here? 2 by 2L under root T by mu minus 1 by 2L under root T by mu, we can write it. 1 by 2L root T by mu, 1 by 2L root T by mu, if I take common, no, 2 minus 1 remain. 2 minus 1 is nothing but 1. Therefore, F2 minus F1 value, how much will get it means here? 1 by 2L under root T by mu, which will get it here. Therefore, if I calculate here, Fn minus 1 value For stretched string, you got like 1 by 2L into under root T by mu. This is also one of the important result which we have to remember here. Now, for example, this is one node we are going to discuss here. Yes. What is the node we want to discuss here? Means, see, for example, they given one wire here, one rope like this. Whose mass is m, whose length is l, whose area is a. We know that, and this radius they given like radius is nothing but small r. You know that mu equal to what we know? Mu equal to mass upon length, you know. Linear mass density, mass upon length. So density equal to what we know? Density equal to mass upon volume. So mass can be written as what you can write? Density into volume if I switch this side. In the place of mass, I'm going to substitute rho into V. Rho into V divided by L. So volume can be written as what, Nana? Area into length divided by L. LL will get cancelled. Area for this case can write as radius is how much? Pi r square, na? Pi r square you can write it. So in the place of mu, what we can substitute? Rho pi r square, which we can substitute here. Therefore, frequency, what we got it here equation, frequency equation we got like F equal to F1, let me write. F1 equal to what we got it here? 1 by 2L into under root T by mu we written. Na? In the place of mu, what we can substitute? We can substitute rho V also. Because rho A, LL will get cancelled. Rho A we can substitute in the place of mu. So that equal to what we can write? 1 by 2L under root T by rho A. Otherwise, I can substitute this value also. So what we can write here? F1 equal to 1 by 2L under root T by, in the place of rho into area, pi r square we can take. Square root will get cancelled. Therefore, r also can come outside. Therefore, what we can write here? 1 by 2L into 2LR into under root T by rho pi we can write it, where T is tension. So as a result, Fnth value if you want to write according to this, Fn can be written as 1 by 2LR into under root T by rho pi. We need to multiply with n. Let me multiply n here only. So this is the nth fundamental frequency in terms of density and radius and length, which we can discuss here. So these are the values which we need to remember, very important for while solving the JEE, NEET, CET numericals. Any competitive exam if you want to perform, no? So these are all the results which we have to remember here. Fine. Next, what we are going to discuss here means we are going to discuss about the Doppler effect. Doppler effect, which we are going to discuss here. So this is also very important topic for JEE, NEET and CET also. For both, they can ask you numericals, they can ask you for both. As it is NCERT topic, which we are going to discuss here. So how can you define Doppler effect? Means it is apparent change in, it is apparent change in frequency of sound waves due to the relative motion between source and observer. Source and observer. For example, let me take here one vehicle we are considering here. One vehicle is there here. Here we are having one siren. That siren can be called as what? Source. Why we can call it as source means here. Why we can call it as? Because this is emitter of sound wave. It's emitting sound, no? Sound wave. For example, one person is standing here. One person is standing here. So when it's making sound, no, that's sound wave traveling into his ear here like this. It's going like this. It's traveling, it is assumed. In this direction, it's traveling. This vehicle is traveling in this direction, let us assume. So this is nothing but wave will be forming here. So who is this fellow? This fellow is going to listen that sound, no? So what we can call it as listener, or we can call observer. Observer we can tell. So whenever train is, or this vehicle, train or anything going closer to him, what will happen? That wave will get that wave will get compressed here. So let us assume this actual frequency is how much? F I'm taking here. So whenever train is going closer to like this, what will happen to him? So that waves are getting compressed like this. Earlier wavelength is how much means this much was there. Now wavelength, if you observe here, no, this much was there. So what happened to wavelength if you discuss here, no? Wavelength will be decreasing. So what we can tell here, if the observer is near, waves get compressed. Waves get compressed. Then what will happen? Wavelength decreases. You can see clearly here, this is wavelength, this is the order of wavelength here. Wavelength is decreasing when object is going closer to the person. So what will happen means we just now we learned that, so far we learned that V equal to F lambda, we know that. V equal to F lambda, you know that. So here sound wave is constant, na? F can be written as what here? V by lambda. V value is constant, na? So what we can write? F is inversely proportional to lambda. What happened to lambda value? Lambda value is decreasing, na, here. If lambda is decreasing, what will happen to frequency? Increasing. So he is going to hear the more frequency. Therefore, he is going to use the high frequency, which we can tell here. When object is going closer to him, he is going to hear more sound. So that one is called what we can call it as the change in apparent frequency is called apparent frequency. The change in frequency is called apparent frequency, which we can tell here. Now, to calculate apparent frequency, so f dash I'm giving that value, apparent frequency. See, we're going to go with one standard formula. What is the standard formula which we created means here? F dash equal to F into V minus V naught divided by V minus Vs, which we know here. This is a formula, universal to solve any type of numericals in Doppler effect. In number of cases which we can solve here. Here F dash is called what we can tell means apparent frequency. Apparent frequency. And F is called what we can tell here? Actual frequency or real frequency. Actual frequency. And here what is V naught means? V naught is nothing but speed of observer or velocity of observer. Velocity of observer. Vs is called velocity of the source. Velocity of source. And what does mean this V tells here means? V is nothing but speed of sound in air. Speed of sound in air. This value also they'll mention in the question how much it is. Sound in air, which we can tell here. This is a standard formula which we need to remember to understand this question. So in this, what we are going to discuss means, so by using this formula, and we have to make one perfect analogy. So F dash F V minus V naught V minus Vs. In this F, these all things if they given means they will ask you F dash. Otherwise they'll give you F dash means they'll ask you F value. This is how they can ask you JEE questions also here. Let me discuss that questions. Here we have observed that if the source is moving towards the observer, then he able to hear more frequency, and vice versa we can mention. Means whenever he is going away, no, that sound will be less we can take. So we have to take one standard sign convention here. What we have to take means here. So let me take here. I'm taking this is my source here. And this is my observer here. Source speed I'm taking as Vs and observer speed we are taking like V naught. And this is the direction of V which we are taking here. This is can be taken as V here, sound wave speed. So every velocity should mention the direction of V here. So what we can tell means first point, let me mention that points here. V from source to observer which we taken. Second point, what we have to remember means all the velocities in the direction of v, is positive, else negative, which we can tell. If anything is going in this direction, we can take positive. If observer is going in this direction, we can take negative. If source is going in the direction, positive, because velocity direction we take it. If source is going opposite direction, we have to take as negative. For example, let me take some different cases here. Also, let me take one case here. In that case, what I'm taking means case 1. In that case, I'm going to take like this. What we are going to tell? Source is moving towards the stationary observer. We are going to discuss. Source is moving stationary observer, which we are going to discuss here. So if you observe, first we need to take the sign convention. This is what here? Source. So this is what here? Observer. This is a sign convention which we choose in here, V. So now what we want to discuss means first, read the topic. Source is moving towards stationary observer. Stationary observer means V0 value should be how much? 0. Then source is moving towards Manana. It's going in this direction. If it's going in this direction, what we have to take? This value can be taken as plus Vs, because going towards this fellow, no? That's why this value can be taken as plus Vs we can take. So what is the formula we're having? F dash equals to F into V minus V0 divided by V minus Vs we are having. So in the place of V0, what will come? 0. In the place of Vs, what will come? Plus. Plus into minus will be minus only. Therefore, F dash equals to what will get it here? Fv by V minus Vs, which will get it here. In this case, for example, they told second case like this. If source is moving away from the stationary observer, source is moving away from the stationary observer, they're telling. So we have to take standard model here. First, what you're having standard model, we taken this is standard sign convention. This is source, this is observer. These both are, this is the direction of speed which we taken. And observer is address means V0 value should be 0. Source is moving away from the stationary observer. Away means it's going like this. It's going in this direction means opposite to the V direction. Now we have to take as minus Vs. So you know that formula, what we know, F dash equals to what we know here. F dash equal to, we know that F dash equals to F into V minus V0 divided by V minus Vs we know here. And V0 value is how much? 0 here. And Vs value is how much? Minus Vs. If I take minus Vs, if I substitute in this, no, minus into minus will become what? Plus. That's why final equation what we'll get here means F dash equals to F into Fv divided by, and then again this F will not come, no? Fv divided by V minus of minus S. Minus into minus will be how much? Minus into minus will be plus. So what we can write it here? V plus Vs will get it. This is a frequency case which we can tell here. So if you observe in this case clearly, plus Vs is there when it's going away. Denominator becoming more. Denominator becoming more means frequency will be less. If you observe in the above case, what we can tell here, V minus Vs. Denominator is decreasing. Decreasing means what will happen? Frequency will be more, which we can tell here.